In this video, we're going to go over section 1.1, where we'll use formulas in the rectangular coordinate system, also known as the Cartesian coordinate system. So the first thing we'll look at, the first example, is finding the midpoint between 2 points, P, which is going to be negative 2, 3, and Q, which is going to be 4, 7. So we want to find the midpoint between these 2 points, and visually what this looks like. So we have our y and x axis, and so our point P is negative 2, 3. So let's say negative 2 is roughly around here, 3 is roughly around here. So this is our point P. Then our point Q is going to be 4, 7. So let's say 4 is roughly around there, and 7 is roughly around there. So plotting Q, we have about that will be our point Q. And so what we want to do here is find the point that's exactly in between these guys. So just eyeballing it, it might be somewhere around there. And so what we can do is use our midpoint formula, which is the following. So we'll denote the midpoint with this capital M here. And our point is going to be x1 plus x2 over 2, comma y1 plus y2 over 2. So our midpoint, our x value for our midpoint is going to be the average of the x values for our 2 endpoints here. And then our y value for our midpoint is going to be the average of our y values for our 2 endpoints, P and Q. So plugging this information in, we know that x1 is going to be negative 2, this x1 here. X2 is going to be 4, so then we have negative 2 plus 4 over 2. And then our y1 is 3 and our y2 is 7. So we get 3 plus 7 here over 2. Right, so then we have negative 2 plus 4 over 2, so that'll be 1. Then we have 3 plus 7 over 2, so it's 10 over 2, so that'll be 5. Right, so this is our midpoint here. And if you look at just this rough sketch here, we kind of estimated that this would be the point. That's kind of close to 1, and this is roughly 5. So this would be our midpoint between our 2 points, P and Q here. Now we're also going to talk about finding the distance between these 2 points. And we'll just use the same P and Q values from above. So if we wanted to find the distance between these 2 points, we'll use our distance formula, which is the following. We have the square root of x2 minus x1 squared plus y2 minus y1 squared. So again, all we have to do is plug in our given information. Going back up here, our x2 is going to be 4, our x1 is negative 2, then our y2 is 7, and our y1 is 3. So we'll plug these in here. So we have 4 minus, our x1 was negative 2, and all of that is squared. Then our y2, was 7. Our y1 was 3, and all of that is squared as well. So following our order of operations here, we have 4 minus negative 2, so that'll be 4 plus 2. So we get 6 in here, and then we're still squaring this. On this side, we have 7 minus 3, so that's 4, and that'll be squared. And all under the square root, okay? Then 6 squared is 36, and 4 squared is 16. And so we get the square root of 52. And then putting this in my calculator, that is approximately 7.21. Right, so this would be the distance between our 2 points. All right, the next formula we're going to look at is the Pythagorean theorem. So we'll use this theorem when we have a right triangle. So there we go. So we have this right triangle here, and we'll use this theorem when we know the length of two of the sides of the triangle, and we're trying to find the length of the third side. So we'll call this side A, this side B, and then our side C is going to be our hypotenuse. And so our formula looks like a squared plus b squared is equal to c squared. And c will always be our hypotenuse. I think I spelled that correctly. It's okay. So c will always be our hypotenuse. So this formula always works where c is our longest side here. And so if we were given sides A and B, this is how we'd find C. And if we were given sides A and C, we would use this and solve for B to find our length B. So let's look at an example here. Let's say we had this triangle here. Here's a right triangle. This length is 5. This one is 9. And then we're trying to find our length C. So using the Pythagorean theorem, we can just plug in these values. So we will have 5 squared plus 9 squared will equal c squared. All right. 5 squared is 25. 9 squared is 81. So this will be equal to c squared. 25 plus 81 is 106. And so we get that c squared is equal to 106. But we still need to fully solve for c, so we'll square root both sides. And we get that c is equal to the square root of 106, which is approximately 10.3. All right, so this is how we would find the length of our hypotenuse here given the length of the other two sides. Next, let's look at an example that you might see on your homework. Let's say we have this sort of structure here. Okay, so maybe you think like a roof. And we're told that the length of this is 32 feet. And then we're told that the height of this guy here is 12 feet. And let's say you were asked, what is the length of the sloping beam? So we want to figure out what the length of this sloping beam is here. Now, if you notice, we have this larger triangle here, but if we were to cut this triangle into two, so just looking at this triangle here, we end up with a right triangle. Additionally, if we were to, since we're cutting this triangle into twos, that means this length here is going to be divided by 2. So the length of this is going to be 32 divided by 2, which is 16 feet. All right, so we have a right triangle, and we have the length of these two sides, and we want to find the length of this longer side. So we'll use our Pythagorean theorem. So we'll have a squared plus b squared is equal to, and in this sense, I'm just calling our hypotenuse x. So we can just do x squared to keep the notation consistent. So we get 12 squared plus 16 squared is going to equal x squared. 12 squared is going to be 144. 16 squared is 256. And that'll be equal to x squared. So then adding those together, we'll get 400 is equal to x squared. And then taking the square root of both sides, we get that x is equal to 20. So that's how we'd use our Pythagorean theorem in a real world example. So that's it for this video.